In the milling and baking industries, the level of starch damage directly affects water absorption and dough mixing properties of a flour, and thus is of technological significance. In the starch damage assay procedure, a highly purified fungal alpha amylase is employed. This enzyme selectively attacks damaged starch granules, producing soluble maltodextrins. Very limited hydrolysis of undamaged granules occur, providing an accurate method for the quantification of damaged starch granules in the presence of undamaged granules. Following extensive interlaboratory evaluation, this method was adopted as AACC method 7631.01 and ICC method 164. This starch damage assay kit and assay procedure can be used for the measurement and analysis of starch damage in cereal flours. It can also be used to measure the degree of gelatinization of starch granules. This video tutorial will demonstrate the use of the kit with the flour sample and the kit control. The kit contains sufficient reagents for 200 assays and is supplied with a detailed data booklet. The principle of the starch damage assay is shown in these slides. Damaged starch samples are hydrated and hydrolyzed to maltosaccharides plus alpha-limit dextrins by carefully controlled treatment with purified fungal alpha amylase. Fungal alpha amylase gives nearly complete solubilization of damaged granules with minimum breakdown of undamaged granules. This carefully controlled reaction is terminated with the addition of dilute sulfuric acid. Aliquots are then treated with excess levels of purified amyloglucosidase to give complete degradation of starch-derived dextrins to glucose. D-glucose is quantitatively measured with glucose oxidase peroxidase GoPod reagent. The amount of D-glucose measured is stoichiometric with the amount of starch damage in the sample. Prior to sample analysis, prepare the required additional reagents as described in the kit data booklet. Subsequently, once all of the additional reagents have been made, the kit components should be prepared, and once prepared, they are ready for use in the assay procedure. Use the contents of bottles 5 and 6 as supplied. Swirl to mix the contents of bottle 1 fungal alpha amylase prior to pipetting. Dilute 1 ml of bottle 1 to 20 ml with 100 mmol sodium acetate buffer, pH 5 containing 5 mmol calcium chloride. Divide into appropriately sized aliquots and store below -10 degrees Celsius. Swirl to mix the contents of bottle 2 amyloglucosidase prior to pipetting. Dilute 1 ml of bottle 2 to 10 ml with 100 mmol sodium acetate buffer, pH 5 containing 5 mmol calcium chloride. Store below -10 degrees Celsius. Dilute the contents of bottle 3 GoPod reagent buffer to 1 litre with distilled water. This is solution 3. This should be used immediately. Dissolve the contents of bottle 4 GoPod reagent enzymes in approximately 20 ml of solution 3. Quantitatively transfer this to the graduated cylinder containing the rest of solution 3. This solution can be either a very light pink or a light yellow colour when freshly prepared, and upon storage it will turn to a very light pink colour. This is the glucose determination GoPod reagent, which is stable for approximately 3 months at 2 to 5 degrees Celsius. Transfer to a 1 litre Duran bottle and cover with aluminium foil. For longer term storage, divide into approximately 250 ml aliquots and store at -10 degrees Celsius. This is stable for greater than 12 months at -10 degrees Celsius and should not undergo more than 1 freeze-thaw cycle. Accurately weigh approximately 100 mg of sample directly into a thick-walled glass 16 by 120 mm centrifuge tube and record the wheat. Gently tap the tube to ensure all of the sample falls to the bottom of the tube. In this demonstration, we are using a flour sample in duplicate and the provided kit control in duplicate. Pre-equilibrate the tubes and the contents at 40 degrees Celsius for approximately 5 minutes. Also, pre-equilibrate the prepared fungal alpha amylase solution at 50 units per ml at 40 degrees Celsius for approximately 5 minutes in a small glass beaker. Add 1 milliliter of the pre-equilibrated fungal alpha amylase solution to each tube. Immediately stir the tubes vigorously on a vortex mixer for approximately 5 seconds to prevent clumping of the flour. Incubate at 40 degrees Celsius for exactly 10 minutes from the time of addition of the enzyme. This incubation for 10 minutes is critical and must be carefully controlled. After exactly 10 minutes from the time the fungal alpha amylase was added to each tube, add 8 milliliters of dilute sulfuric acid solution, 0.2% volume per volume, and stir the tube vigorously for approximately 5 seconds. This inactivates the enzyme and thus terminates the reaction. Centrifuge the tubes at 3000 RPM for 5 minutes. Carefully and accurately transfer 0.1 milliliter aliquots in duplicate of the supernatants from the centrifuged samples into the bottom of labelled glass test tubes. It is important to ensure that the sample aliquots are delivered directly to the bottom of the tubes to ensure complete mixing with amyloglucosidase. Add 0.1 milliliter of the prepared amyloglucosidase solution at 20 units per ml to each tube to complete the degradation of starch-derived dextrins to glucose. Stir the tubes on a vortex mixer and incubate at 40 degrees Celsius for 10 minutes. Glucose standard solutions are prepared by adding 0.1 milliliter of bottle 5 D-glucose standard solution at 1.5 milligrams per milliliter, plus 0.1 milliliters of acetate buffer to tubes in quadruplicate. Prepare reagent blanks by adding 0.2 milliliters of acetate buffer to tubes in duplicate. After the 10-minute incubation period, remove tubes from the water bath and add 4 milliliters of GoPod reagent to all tubes. Including the glucose standards and reagent blanks. Incubate all tubes for 20 minutes at 40 degrees Celsius. Measure the absorbance of each solution at 510 nanometers against the reagent blank. Use the absorbances to calculate the content of starch damage. The absorbance readings of the sample and the blank reactions are used to calculate the starch damage content of the test sample on an as-is basis. When performing this test on the megaquant wave spectrophotometer, the absorbance mode feature must be used. The results will be printed via the onboard printer, or the data can be exported to a computer using the SF Capture software. Please see our megaquant wave video for further details. In absorbance mode, the results output are raw absorbance values for both blank and samples. Therefore, the calculations of starch damage can be performed manually, as described in the calculation section of the kit booklet. Megazyme has also developed specific Excel-based MegaCalc applications for each Megazyme kit to allow quick and easy results analysis. Results can be analysed using the MegaCalc application specific to this starch damage assay kit, which is available to download free of charge from the Megazyme website. The MegaCalc spreadsheet provides full instructions for use. Open the MegaCalc worksheet and input the following: sample details, absorbance readings for the D-glucose standards. For each sample, input the sample identifier. For each sample, input the absorbance values recorded in duplicate. Input the recorded sample weight used. Alter the volume of sulfuric acid solution if a volume other than the default 8 ml has been used. The extract volume will then be automatically calculated. If dilution of the sample has been performed prior to the GoPod assay, then input the dilution factor used. If no further dilution was performed, the dilution factor is 1. When all of the data has been entered, the content of starch damage in the sample is automatically calculated and given as % weight per weight on an as-is basis. For further information on this method and on the collaborative evaluation of this starch damage assay kit, please see papers by Gibson et al.